Right now, somewhere in your kitchen, there is a war happening. It has no sound, it has no smoke. It has been going on since the moment you closed that door, and it will not stop until you open it again. You call it a fridge. Your food calls it a battlefield. Because the truth is far stranger than keeping things cold. Your refrigerator is not stopping bacteria. It is holding a losing fight against them, 1 degree at a time. Here is what you were never told in school. Bacteria do not care that it is cold in there. Most of them just slow down, a few of them speed up, and one very specific, very dangerous species treats your refrigerator less like a prison and more like a comfortable second home. Start with the number nobody explains properly. Food safety scientists call it the danger zone. It sits between 40 and 140 degrees Fahrenheit. Inside that range, bacteria can double their population in as little as 20 minutes. 20 minutes. That means a single bacterial cell left on your counter at room temperature could become over 1 million cells in about 7 hours. Your fridge exists purely to drag your food out of that window as fast as possible. Not to make it safe, just to slow the war down enough that you can eat before the enemy wins. This idea that invisible organisms are attacking your food is newer than you'd think. For most of human history, spoilage was blamed on bad air, or moral corruption, or the wrong phase of the moon. It took a French chemist named Louis Pasteur in the 1860s to actually prove that microorganisms, not mystical forces, were responsible for food going bad. Pasteur heated broth in swan-necked flasks and showed that as long as airborne microbes couldn't reach the liquid, it stayed clear and unspoiled indefinitely. The moment he tipped the flask and let dust and microbes in, the broth turned cloudy with bacterial growth within days. That single experiment quietly rewrote how humanity understood food, illness, and decay. Suddenly, spoilage wasn't a curse. It was a battle, fought at a scale too small to see. So if bacteria are the invaders, cold is the weapon. But here's the part almost nobody stops to think about. Cold doesn't kill bacteria. It just makes them sluggish. Refrigeration slows the chemical reactions bacteria need to multiply. The same way cold slows down almost every chemical reaction on Earth. Drop the temperature low enough, and most bacteria can barely function. But barely functioning is not the same as dead. It's more like putting an army to sleep instead of defeating it. The moment conditions warm back up, even slightly, that sleeping army wakes up exactly where it left off. And this is where your fridge stops being a fortress and starts being something closer to a stalemate. Because there is a category of bacteria that doesn't slow down much at all in the cold. Scientists call them psychrotrophs, meaning cold-loving. The most notorious example is Listeria monocytogenes, a bacterium capable of slowly multiplying even at standard refrigerator temperatures, quietly building its numbers over days and weeks while everything looks and smells completely normal. That's the part that should genuinely unsettle you. Your nose is not a reliable defense system here. Spoilage bacteria that make food smell rotten are often not the dangerous ones. The truly dangerous ones can multiply silently, leaving no smell, no color change, no warning at all. Why would evolution let something like that exist? Because bacteria aren't trying to hurt you. They're trying to survive, reproduce, and spread using whatever environment happens to be available, and your leftover chicken is just another environment to them. The fact that it also happens to be your dinner is, from their perspective, completely irrelevant. Now think about what actually happens every time you open that door. You're not just checking on your food, you're breaching the wall, warm air rushes in, humidity shifts, surfaces briefly climb a few degrees warmer, right as new bacteria drift in from your hands, your counters, and the air of your kitchen itself. Every single time. A fridge that's opened dozens of times a day, as most are, is less like a sealed vault and more like a border crossing that never fully closes. This is where a completely different kind of research becomes relevant. In 2016, food scientist Donald Schaffner at Rutgers University ran a now famous set of experiments testing something almost everyone has an opinion about: the 5-second rule. His team dropped food onto different surfaces and measured exactly how quickly bacteria transferred. What they found surprised almost everyone. Transfer happened essentially instantly, in far less than 5 seconds, and the amount of bacteria that moved depended far more on the surface, the moisture of the food, and the type of bacteria than on timing. There was no safe window. There was no grace period. The moment contact happened, the transfer had already occurred. That single study quietly ended a decades-old kitchen myth, and it says something bigger about how your fridge works too. Bacteria don't wait for convenient moments. They act the instant an opportunity appears. And so every jar, every container, every piece of food sitting in your fridge right now has its own bacterial population, growing at its own pace, completely indifferent to your expiration dates. Speaking of which, here's something worth sitting with for a second. Most expiration and best buy dates aren't strict safety cutoffs at all. In most cases, they're manufacturer estimates of peak quality, not the exact moment your food becomes dangerous, which means the date on the label is really just an educated guess about a war it can't actually see happening inside your fridge. There's another twist buried in the history of cold food preservation that most people never learn. The idea of deep freezing food to preserve it wasn't invented in a lab. It came from careful observation of Arctic life. In the early 1900s, American naturalist and inventor Clarence Birdseye spent time in Labrador, Canada, where he noticed something remarkable. Fish caught by local Inuit communities and frozen almost instantly in the intense cold tasted fresh, even months later, in a way that slow frozen fish never did. Birdseye realized the difference wasn't just temperature, it was speed. Freezing food quickly formed tiny ice crystals that didn't rupture the food's cellular structure, while slow freezing formed large, jagged crystals that tore cells apart from the inside, ruining texture the moment the food thawed. That single insight became the foundation of modern flash freezing technology, the same principle keeping your frozen vegetables intact today. Cold alone was never the answer. How you got there mattered just as much, which brings you back to your own refrigerator, quietly running its war 24 hours a day. Every shelf holds a slightly different battlefield. The door, exposed to the most temperature swings every time it opens, is actually the warmest and least stable zone, which is exactly why it's the worst place to store anything genuinely perishable, no matter what the built-in egg and dairy compartments suggest. The back of the bottom shelf, meanwhile, tends to be the coldest and most stable, precisely because it's farthest from the door and closest to the cooling element. Your fridge isn't one uniform cold zone. It's a landscape of tiny climates, each one favoring a slightly different set of bacterial survivors. So, what does this mean for you standing in your kitchen tonight? It means the cold humming behind that door was never a guarantee. It was always a delay tactic, bought through chemistry, refined through more than a century of science, from Pasteur proving invisible life was real, to Birdseye discovering that speed mattered as much as temperature, to modern researchers still uncovering exactly how fast bacteria move the instant they get a chance. None of that technology defeated the war. It just slowed it down enough that humans could finally win the only battle that actually matters: eating before the invaders do. So, the next time you close that refrigerator door, listen for the hum. That sound isn't just electricity. It's the sound of a war being held at bay, 1 degree at a time, for exactly as long as it can be.